Okay, let's do Chapter 10, Section 2. And let me just remind you of some things. So we're dealing with equations. So remember, with an equation, there's an equal sign. In the variables, x and y. For example, this is just one example out of an infinite number. X minus y is equal to 2. So here are some things that we've learned. That a given pair, x and y, that make the equation true is called an ordered pair solution to the given equation. So that's one thing we learned. Another thing we learned is that given a particular equation, like this one here, this is what I'm talking about, that we can have more than one ordered pair solution. For example, 4 and 2 works. Remember, this is the x value and this is the y value. So if x is 4 and y is 2, then 4 minus 2 is equal to 2. 6 and 4 works. 7 and 5 works. In other words, the point is there are many times an infinite number of such ordered pair solutions. And here is probably the most interesting and helpful of all of the points I could make, and that is the following. We can create a set of all of the ordered pair solutions. The set of all ordered pair solutions correspond to an infinite number of ordered pairs, clearly. I'm going to give you a graphical example of this in just a second. These are just the concepts. And here is the point. The corresponding graph of all of these ordered pairs forms a straight line. And of course that graph takes place in the rectangular coordinate system. For this reason, so that's the important part. So for this reason, these types of equations into variables are called, and it won't be a surprise at all to find out what they're called. They're called linear, see the word, the root of line, linear equations. And again, I'm going to show you an example in just a second. I just want to set kind of, sometimes we don't say things explicitly, which we need to say explicitly. We kind of take it for granted that you've figured it out. So I'm saying a lot of things explicitly right now. And the fourth point is just a reminder. We have a mathematical object. And in this case, it's an ordered pair. For example, -1 and 3. So this is the mathematical object. Then we have the graph of the mathematical object. And the graph is visual. And that's what makes it so important, is we can visualize mathematics with our eyes rather than with just the organ of our intellect or brain. So the graph of the mathematical object in this case is a point. So given, with this in mind, given a particular equation, x minus y is equal to 2. So this is an equation in 2 variables. That's the mathematical object. It corresponds to another mathematical object, which is a set. It's called the solution set. It's all ordered pairs, x, y. So there's just an infinite number of these. The straight bar is read such that x minus y is equal to 2. And we already saw some things which are in the set where it's impossible to list all of them because there's an infinite number. For example, the set will contain 2, 0. That's one ordered pair. 4, 2. That's another. 3, 1. That's another. And just a whole bunch of ordered pairs. So that's some of the elements that is in this set. And this set is called the solution set for this particular equation. Now again, this is just concepts. You're not going to be tested on this, but I kind of want to paint the big picture for you. And the graph, the corresponding graph, the visual aspect of this mathematical object will literally be a straight line. So let's actually do that. Let's take a look at that. So here I'm going to use GeoGebra, and I'll write down that word in just a second. And over here on this part where it says input, it will actually, let's actually just show you first. So first, here is 1 point. notice that it draws a line. And through a single point, this is going to be important later on, there is an infinite number of lines that you can draw. So a single point does not define a line. But if I choose another point, and you should be able to verify this point here is the x value is -1 and the y value is 1. So this point here corresponds to -1 and 1. And point B corresponds to, well, my x value is 1, but my y value is 0, and it corresponds to 1, 0. That as soon as I fix 2 points, there's a unique line through those 2 points. So let's turn these off. And let's actually go back to something altogether. I just want a clean screen here. So let's just delete some of these objects. And let's go back to what we were looking at before, the equation x minus y is equal to 2. And right here we will see that we are given the visual representation of every solution to that equation. So if I pick a point anywhere on this line, it's going to have some x value and some y value. And when I plug that x value and y value in to my equation, x minus y is equal to 2, I will get a true statement. So that's what's that's what's going on. So let's go back and see what we're supposed to be doing. I need to make this smaller. So I just defined a linear equation in 2 variables, and let me give you a more general definition. So a linear equation in 2 variables, and for the most part our variables will be x and y. When would we change those variables? Well, sometimes we want my x to stand for time, and sometimes I want my y to stand for amount of money earned. But it doesn't matter. Variables are always dummy letters that you decide. So a linear equation in 2 variables, and in this case I'm going to use the variables x and y, is given by a times x plus b times y is equal to c. So I have to fill in some details, right? Where a, b, and c are constants. And by constants, I mean real numbers. But there's one other ingredient, and we have one more fact, and A and B are not both 0. And by that I mean equal to 0. So that means one of them can be equal to 0, but another one's not. So let me show you really fast that the equation that we were just looking at has this form. So that's actually called a linear equation in general form. ax plus by is equal to c. And we were just looking at the equation x minus y is equal to 0. So that means, so here it is, that's the same as 1x minus 1y is equal to 0. Or if you prefer, that's the same as 1x plus minus 1y is equal to 0. So it's easy to see that a is equal to 1. b is the coefficient of the y variable. b is equal to minus 1. And c, we were using a plus by is equal to 2, but I forgot and I wrote down 0. It doesn't matter. C is equal to 0. This is just another linear equation. So it holds, it has this general form. X minus y is equal to 0. A is equal to 1. B is equal to minus 1. And C is equal to 0. So by definition and by a theorem, I know when I look at all of the solutions to this particular equation and I graph it, my graph is going to be a straight line. So what we're going to do is learn how to find and produce the graph of a straight line. And here's what comes into play. So we're going to be doing 1A now. So we're going to be given an equation, x minus y is equal to 2. And we're asked to find 3 points that lie on that line. So in the first case, it's going to be an expansion of what we were doing in our lecture 10.1. They're going to give you one of the variable values, and you're going to find the other one. In this case, in one case, they're going to give you 3, x is equal to 3. In another case, they're going to give you y is equal to minus 2. And in the third case, looks like they give you x is equal to minus 1. So what we have to do is we have to find out what value goes in here. Fill in the y value. So we're going to look at these one row at a time. We're looking at these as rows. And we're going to fill in the other value. So let's go back to the way we did it yesterday, or the last lecture, whenever you watch that. So here is my general equation, x minus y is equal to 2, and they've given us the ordered pair 3y. So your job is to find the corresponding value of y. So remember, these come in always values of x, y. So in this case, my x is equal to 3. So I'm going to plug in my 3, but my y is my unknown value. So I'm solving for y. So what I'm going to do is I'm going to move the y to this side, and I'm going to move the 2 over here. When I move the 2 across the equation, across the equal sign, it becomes minus 2. And when I move minus y, I'm moving all of this. I'm moving y together with its sign. Across the equal sign, it becomes plus. So 3 minus 2 is 1. So 1 is equal to y. So I just found the answer, the corresponding answer to this row. The corresponding value is 1. And over here, if you want, you've got to make sure you make this connection that I've discovered that y is equal to 1. That's what these points over here mean. So when x is 3, y is 1. So that translates to the ordered pair This translates to the ordered pair 3 and 1. So we're going to do the whole thing again. You're going to be doing a lot of this. So remember that none of it is really more difficult than what we're doing right here. So we found the value of row 1. So now we're looking at row 2. And in this case, our unknown value is x, because that's the blank, but our y value is minus 2. So they want us to find the corresponding value of x. So here you have to be very careful. X is my unknown minus, and for y, I have to replace the literal symbol y. Y is my variable with the value given here, which is minus 2. And that's equal to 2. Now I'm ready to solve for x. So minus a minus 2 is a plus 2. So I'm almost ready to solve for x. I'm going to take this value, plus 2, and move it to the other side. I always grab its sign. So x becomes 2, and when it gets to the other side, it becomes minus 2. So that gives me x is equal to 0. So this value is 0, and I found the corresponding value of x over here is equal to 0. So again, I found another ordered pair, 0 and minus 2. I'm going to jot these down because I'm going to plot them. I'm going to go and we're going to plot them in just a second and verify that each one of these points make up a line. So the last thing we're going to do for this particular problem, not the last thing we're going to do in this exercise, is the last row. In which case we're given that x is equal to minus 1, but y is our unknown. So again, I replace my variable x with minus 1. Then I have minus y is equal to 2. So in this case, I'm going to do it in 2 steps. I'm going to take my minus y and move it over here. So when I move my minus y over there, it becomes plus y. But I want to get y by itself, so I'm going to take my 2 here, and it's a positive 2, and I'm going to move it over here. In doing so, it becomes minus 2 minus 1 is equal to y. So that gives me that minus 3 is equal to y. So over here I get minus 3, and I have the following 3 points. Minus 1 and 3. So we can actually check to see if these are all correct. Well, one way to check them is literally just to look at our original equation, which is again this, and we can plug in each one of those values for x and y and make sure they're true. If I plug in 3 for x and 1 for y, it's true. If I plug in 0 for x and minus 2 for y, then I got 0 minus a minus 2, which is 0 plus 2, which is 2. So that works again. And minus 1 minus 3. So is that right? Minus 1 minus 3 is the same as 3 minus 1, and that is 2. But now I'm going to show you the graphical way we could check our answers. So what we're going to do is we're going to plot three and 1. So I'm going to grab my point object and I'm going to plot 3, 1. So my value of x is 3, and then I go up, and there it is, 3, 1. The next point, so you all should write these points down or look at your notes. The next point is 0, 2. So the x value, minus 2, sorry. So the x value is 0, and the y value is minus 2. And I'm actually just right now, because I'm curious, I'm going to draw a line between those 2 points. And in this case, you're actually going to be doing this on your own. And I'm using the computer to do it because I don't really have a good way to have graph paper on my screen. So my third point is minus 1 and 3. So here's my minus 1, and when I plot this point, it should be on the line, the existent line. So here's my minus 1 is my x value. And I wrote it down wrong. It has to be 0 minus. It has to do minus 3. What did I do wrong? So something's wrong. Let's go back and see. Let's check my algebra. Go back to get rid of that. So this is good because my point that I had written down, did I just write it down wrong? Is minus 1 and 3, and this is minus 1 and 3 up here. And you can see that it does not lie on this line. So let's go back and find our error. So my error came right here. I have minus 1 and 3, so let's do it again and see what I did wrong. So x is minus 1, and then I'm solving for y. Minus y is equal to 2. So I think I just forgot. So again, I'm going to bring my y over here. And you all probably saw me do this error. And it may have just been I copied it down wrong. But this is good because I literally wanted to show you how you catch errors this way. So that gives me minus 1 is equal to 2 plus y. And now I'm going to move my 2 over to here, and it becomes minus. So I get minus 3 is equal to y. So that needs to be a minus there. And we actually just discovered it on the graph. So here is the thing. We can visually, what we just learned, is we can visually check our solution. So again, this is the power of the invention of the coordinate axis, or of the coordinate plane, or the XY plane, is we have ways of visually checking whether something is true, and then we have algebraic ways, which are far from visual, right? They're rule-based. Algebraic are rule-based. So this is the first unification of the visual with the algebraic. And if any of you are video gamers out there, how do you think the computer knows how to draw the characters in your video game? Well, it's using a lot of massive raw data, but it's using a lot of algebraic manipulation. And clearly it's using something similar to the XY plane. Let's go ahead and do the next problem. So in this case, got a brand new problem. So down here, what you would do if you're doing this at home, so down here we would have 3 and you should have 1 right here in the Y place. So you'd go over 1, 2, 3, 1. You'd put a dot right there. Then you would come down here and you have 0 minus 2. So you put a dot right there and you would use a ruler and draw a line through your dots. And then you would go 1 minus 3 and put a dot right there and check that it actually is on the line you just drew. So the next one we're going to do, I'm going to jot this down because I'm going to get rid of this screen, is y is equal to minus 1/3 x minus 2. And I guess we'll just use this right here. I'm going to try to make all of this work, people. So keep that right here and let's start erasing. Oh. Ooh. Just being slow today. It's just one of those days. So in this case, I'll make it a little bit smaller to erase what's in here. We're given, I might just be able, let's just see if I can't use what's up here. Y'all can look at what I have up here. See if I just can't wisely use my space down here so I don't have to try to recreate this table. So decrease, decrease, decrease. Get back to my pen. So in this case, we're given the equation. So this is 1b. So we're given the equation y is equal to minus 1/3 x minus 2. So the first thing we're going to do with this equation is I'm going to change it to a different equation that has the exact same solution set. I'm going to multiply both sides by 3. Why? Because I like to clear the denominators. Remember, I have to multiply the entirety of both sides by 3. So this is 3y, that's easy. 3 times minus 1/3 y. So 3 times minus 1/3 x is the same as 3 divided by 3, which is 1, times minus 1, which is minus 1, times x, which is minus x. And then the next one, remember I'm just using distribution right here. I'm multiplying 3 times each term, so now I have to multiply 3 times minus 2, and that's going to give me minus 6. So I would rather use this equation. Maybe I shouldn't have erased that. Maybe. You can always pause this and go back. If you forgot to copy it down before I started erasing, just pause it and go back. So this is literally going to be what we're going to use. You don't have to. You could have plugged it into the original, and we're given decrease. We're given an x value of 6, but not the y value. So we have to find the corresponding y value. That's what that table is. It says x is, remember these are the values of x, y. So we're given that x is equal to 6. So the question is, if x is equal to 6, what is the corresponding value of y? So let's do that. So x is equal to 6. So I'm going to go 3y is equal to minus. Remember, I replace x, just x, with 6. Had this been minus 6, I would have had to replace x with minus 6 and wrote minus 6 in parentheses. So let's solve for y. So it gives me 3y is equal to minus 6. Minus 6 is minus 12. So that's how many 3y are. So let's find out how many 1y is by dividing both sides by 3. And that's going to give me y is equal to minus 12 divided by 3 is minus 4. So I just found the value of y, and the value of y when x is 6 is minus 4. So up here you would, if you're doing this on your worksheet at home, you would add minus 4 right there where the y is. So let's do another one. The next one, we're not given the value of x. Our value of x is unknown. But they say the value of y is minus 4. Is this a trick? It's not a trick. We actually know what the value of x has to be. It's literally whenever x is 6, y must be 4. And whenever y is minus 4, x must be equal to 6. So literally, I already know the answer here. And this was not done by mistake. It was done so you realize that once you find a value of x, the corresponding value of y tells you what the value of x is. Almost in every case. There's a few examples where that's not true, but those are rare, and we'll get to those later on. We won't worry about them. So I have these, both of these are the same point. Why? Because they say I have the same exact value of x and the same exact value of y. You can think of the same point are things with the same address. And the x address is 6, and the y address is minus 4. So let's do the last. They don't give us the x value. They give us the y is equal to 0. So let's find the x value. So I plug in 0 for y, and everything else stays the same. So 3 times 0 is 0. That's equal to minus x minus 6. So I want my x to be positive and all by itself. So one way to accomplish that is to take this minus x term and move it to the other side. And when I do, it becomes positive. So I get plus x plus 0 is equal to minus 6. But x plus 0 is just x is equal to minus 6. So I found 2 points, and those points are 6 and minus 4, and minus 6 and 0. So let me jot those down. So at home, what you need to do is you need to try to plot those down here. So our first point is 6 and minus 4. So I'm going to go 1, 2, 3, 4, 5, 6. Then I'm going to go down minus 4. 1, 2, 3, 4, and I'm going to put a dot right there. But that's what I'm going to do over here. Let me delete all of this. So I'm going to plot 6. Here's my 6. I'm going to come down to minus 4. I'm going to put a dot, a point. I shouldn't call it a dot because it's not a dot, it's a point. And then the next one I'm going to plot is x is equal to minus 6. So this is my x-axis. So minus 1, minus 2, minus 3, minus 4, minus 6. And my y is equal to 0. So that lies on the x-axis. And now I'm going to draw a line between those 2 points. And that line represents the graph of the line given by the equation y is equal to minus 1/3 x minus 2. Notice we're going to have another point right there. I don't want to do that. We're going to have another point right there at 0 minus 2. So, number D is going to be interesting. So for right now, let's do number C. And for number C, this is 1C. I try to remember to do this in case you're fast forwarding and you want to know when to get to number 1C. If that's up there, you can find it. We have the equation y is equal to 2/3 x. Now, if you want to, you can clear the denominators. So I'm going to give us 2 choices here. This is the same. I'm going to multiply both sides of this equation by 3. So when I multiply the left side of the equation by 3, I get 3 times y. And then when I multiply the entirety of the right side by 3, I'm going to have to do some simplifications. So I don't like the way I did that fraction here. A lot of times students are careless, and I know we should make sure that the x does not appear in any way in the denominator. So that's 2/3 times x. So let's simplify that. There's nothing to simplify on the left-hand side, but on the right-hand side, 3 times 2/3 x. So this is 3 numbers multiplied together. 3 times 2/3 times x. So this is the same as 3 divided by 3, which is 1, times 2, which is 2, times x. So that's 2x. So I can use either of these equations. The solutions xy for this equation here are exactly the same for this equation. In other words, whatever ordered pair xy, where x and y are specific numbers, make this equation true, then that same exact set of specific numbers will also make this equation true. So I can go back and forth as I want. And that's using the power of algebra to help us solve things, because I use the multiplication principle of equality. if I multiply any equation on both sides by some non-zero constant, I get the same solution. So here we are given that x is equal to minus 6, and we're asked to find the value of y. So again, a lot of solving of, notice as soon as I plug in the value of x being minus 6, I just have an equation in a single variable, and we've been working quite a bit in Chapter 9 to solve those types of equations. So y is what I'm looking for, it's our unknown. So 2/3, and x becomes minus 6. Well, that's the same as y is equal to 2 times minus 6 over 3, which is equal to 2, and minus 6 divided by 3 is minus 2, so that's equal to minus 4. So y, in this case, turns out to be minus 4. So I found one ordered pair solution, minus 6, minus 4. So I'll write these over here. Minus 6 and minus 4 is one ordered pair solution in the very, very large solution set of this equation. So let's get back to my eraser. And let's do the next one. In the next one, we're given our x is our unknown, but our y value is equal to 0. So that corresponds to our y value is equal to 0. So I'm going to plug in 0 is equal to y. And notice I could use this one. As a matter of fact, let's use this one just to show. So this is 3 times 0 is equal to 2x. So 3 times 0 is 0, and 0 is equal to 2x. So I'm going to divide both sides by 2. Notice I'm dividing 0 by 2. I'm not dividing by 0. So that gives me that 2 divided by 2 is 1, so 1x, or just x, and 0 divided by 2 is equal to 0. So that gives me my answer. My answer is x is equal to x is equal to 0. So I found another ordered pair solution. Didn't mean to do that. I don't know if y'all can see that that may be just as good. That gives me more working space. So we have another ordered pair solution, 0 and 0. And the final thing that we're given, let's erase some of this stuff. Remember, you can use either of these two equations. It does not matter. So our final one that we're given is that y is equal to 10/3. Our x is our unknown, but y is equal to 10/3. And here I think the choice will be pretty easy. We need to use this equation right here. Well, I'm going to let you do it the other way, and you'll discover we're going to use this equation. So y, 3 times y, but y is equal to 10/3, is equal to 2x. I hope you already see why I chose that equation. So 3 times 10 thirds is the same as 3 divided by 3, which is 1, times 10. So that becomes 10. And this is equal to 2x. So that's how many 2x is. So I can divide both sides by 2. And 10 divided by 2 is 5. 2 divided by 2 is 1, and 1 times x is x. So in this case, x is equal to 5. So we have 3 ordered pair solutions. 5 and 10 thirds, 0, 0, and minus 6 and minus 4. So let me write those down and let's plot those. Minus 6 and minus 4. 0, 0, so the origin, that's really easy. And 5 and 10 thirds. So again, you all need to learn how to plot them here, but I need some electronic form where I can plot them using what I have here. So we're going to do it in GeoGebra. So the first one I'm going to plot is the origin, right there. That's the 0, 0. Now I'm going to do minus 6 and minus 4. So my value of x is minus 6. And then I'm going to come down to my corresponding minus 4 line. And now literally, if I want, I can draw a line through there. And now let's check my last point. My last point says let's find 5, x is equal to 5, and y is equal to 10 thirds. So that's 3 and 1/3. So let's find my 5, and let's go up to 3. There's 1, 2, 3, and indeed right there it is. So there are the 3 points that I just found, and they all 3 lie on the line. So this corresponds, it says 4.98 and 3.32, but that's just because I'm eyeballing it. It should be 5 and 3.33. But this is my 5 and 10 thirds. This is my 0, 0. And this one down here is my minus 6, minus 4. So let's look at this aggravating next one. It seems really weird. But it's not. And here is what I'm going to do. Before we even do this, I want to get a whole nother set, a clean space here. So remember that my general equation in 2 variables is ax plus by is equal to c, where my a, b, and c are constants. My variables are x and y. If you don't like the term variables, use the word unknown. My unknowns are x and y. So I want to show you that this is literally, and what do I know? I know that any equation that can be written this way has a graph, which is a straight line. But here I'm given that y is equal to minus 3. So what I wrote there, y is equal to minus 3, corresponds to problem 1D. So that means my b is equal to 1. So let's remind ourselves a, b, and c are real number constants. I say constants because they're not variables. They don't change. They're fixed. And there is one other condition. And a and b are not both 0. In this case, b's not 0, so that means a can be 0. So it has to be 0 because this term here has to be 0 because there is no x up here. So that's the same as 0. If I want to literally force an x in there, 0x plus 1y is equal to minus 3. So my a is equal to 0, my b is equal to 1, and my c value is equal to minus 3. So what we know, and you just got to believe me, that this equation, y is equal to minus 3, is a linear equation. And when we graph it, it's going to be the graph of a straight line. So let's start again with what we were given. So this is 1d. So we have y is equal to minus 3. And here we have our little table, which I am going to try to duplicate over here, because there's really nothing to be done. So 2, they give us values of x, minus 1 and 0. So I've got to find the value of y. And whatever value of y I put in here, or here, now this is not a 0. Let me erase that. Bad choice of symbols. Whatever I should use a box. It was supposed to just be a circle. Whatever I put in here, in this row, in this column, this row, and this column, and this row, whatever I put in here has to make this true. But this says y equals minus 3. So that means y always has to equal minus 3. If I put any other value in there for y, like 0 or 1, then this would no longer be a true statement. Because then I would be saying y is equal to 0. But this clearly shouts y is equal to minus 3. So we have 3 different points. 2, minus 3, minus 1, minus 3, and 0, minus 3. So in this case, we're going to note that the y coordinate, the y direction, is always 3, minus 3 actually. So let's actually plot those points. 2 minus 3, minus 1 minus 3, and 0 minus 3. So let's go over to our plotting. So for those of you who are wondering about this, this is GeoGebra, GeoGebra.org. And that's what I'm going to in the next page, GeoGebra.org. And it will give you something very similar to this. So let's plot 2 and minus 3. So here's my 2 on my x-axis. So I'm going to go down, keeping, this is, so if you think about it, the 2 street runs north and south. I'm going to stay down on the 2 until I get to, what is it? Oh yeah, of course, minus 3. My next value is minus 1. So here's my minus 1, runs everything up on this little line, corresponds to x is equal to minus 1. And I have to land on minus 3. So let's draw a line between those 2 points. Wow, it's a horizontal line. Well, let's plot our very last point just to make sure. X is equal to 0, so this is my 0 line. but y is equal to minus 3. And right there it goes. So I literally have 3 points, all of which lie on a horizontal line. So we just learned something. So what we just learned is the following. The graph of a horizontal line, and this is something you need to know. And remember, horizontal lines are ones that go horizontally. They are parallel with the x-axis. A horizontal line is given by any equation that can be transformed. Now I'll give you an example of what I'm saying right here. Algebraically, to y is equal to c for some real number constant c. So what do I mean by this phrase right here? Transformed algebraically? Because this is obvious. Y is equal to c. If you're given, for example, y is equal to minus 1, you know that's a horizontal line where y is always equal to minus 1. But what do I mean about transformed algebraically? And it's really not as bad as you might be thinking. Suppose I have something like this. And the reason I'm doing this is because I know you're going to see them. Y plus 1/2 is equal to 3/2. Well, as soon as I solve for y, so that's the equation. So here's my algebraic transformation. What is my algebraic transformation? It's a fancy word for moving the plus 1/2 term to this side and solving for y. That's the same thing as y is equal to 3/2 minus 1/2, which is the same as y is equal to 3 minus 1 over 2, which is the same thing as y is equal to 2 over 2, which is the same thing as y is equal to 1. So through algebraic transformations, I was able to transform it into y is equal to c. In this case, c is equal to 1. So this is going to be, if this is my coordinate system, here's my y-axis, here's my x-axis, and this is the point 0, 1. Literally, this is going to be a graph. I probably should have shown a different color, but too late. This is the graph of the equation y is equal to 1. So this is my x-axis down here and my y-axis up here, and this is a horizontal line. So while I've got you here, like you're going anywhere, you can turn it off at any time. Let's look at some other things. Again, I'm going to draw just to the best as I can a rough sketch. So this is my x. And this is my y. So get us another color here. So this is a horizontal line. And since this point right here corresponds to 0 and some positive value b, this is the graph of the equation y is equal to b for some b that is greater than 0. Like, for example, y is equal to 3. What about vertical lines? This is a vertical line, straight up and down. And it's going to go through a point right here. And this point is going to be some number c, and my y is going to be 0. And every point down here, the x value is going to be c. So what we just discovered, and we'll see it here and soon, the corresponding x is equal to c for some constant c. For example, x is equal to -5 is, you ready? Drum roar. The graph of a vertical line. So those are two facts that you're going to need. The graph of a vertical line is x is equal to c for some constant c, and the graph of a horizontal line is y is equal to c for some constant c. So play around with that. It's really easy to get those two confused. So one last thing. We've got 3 more. Yeah, we have a bit more to do, so let's do them. Whoops, I hit the wrong thing. Give me some new white space here. And let's go to the next page. So literally here, they graph the following linear equations. And you should, when you do this at home, you need to graph it you yourself, not using the GeoGebra like I'm using, because I just need a computer to put points on a graph, and that's the reason I'm using it. You need to use that graph right there, this graph. So let's do this first one. So what do we know? We know that if I find 2 points, we know this is this still question number 1? This is 1. This is 1e. So we know that 2 points make a unique straight line. And again, we showed you that when we went over here, and I grabbed this and it says, oh, I'm going to put 1 point right there, and that's just 1 point, and there are literally an infinite number of lines that can be drawn through that 1 point. As soon as I settle down on another point, then I can no longer move that line. If that line is going to go through those 2 points, it can't move from that point out. So 2 points make up a unique straight line. That's something that's been known since the time of the ancient Greeks. So what we have to do is we're given an equation in two variables, x plus y is equal to 0. So our goal is to find at least two ordered pairs, at least two, 3 is fine, ordered pair solutions to this equation. That's our goal. So, but you're saying, oh no, in the past I was able to do it because they gave me some value of x, for example, like 3, and then I was able to find the corresponding value of y. Or sometimes they gave me the value of y, like 7, and then I was able to find the other value for x. Well, guess what? We can do that same exact thing too. If I go back, and let's just look at a generic line. Almost in every case, I'm going to draw a line here. So choose any value of x you want, and you can move up and find a corresponding value of y that makes the equation true. Down here, on this side, I might have to move down. If I choose x is equal to 6, I can move down, and I always run into the graph. So, and it would also be the same if you chose a value of y. So choose a value of 1, I can move over and find a corresponding value of x. If I choose 2, I can move down and find a corresponding value of x. If I choose this, I will find a corresponding value of x. So what I'm trying to show you right there is for every value x you choose, as long as it's not a vertical line, you will be able to find another value. So I'm going to pause this right now. My phone's ringing.